Today we are going to start the chapter number 1 from AqA Computer Science, and the chapter number 1 is Fundamentals of Algorithms. So the question is, what is algorithm? So the answer is, an algorithm is a step-by-step sequence of instructions that are used to solve a problem or complete a task. Each instruction in an algorithm must be precise enough to be understood independently. So in simple definition, algorithm is the step to make a program, right? So we need to follow the steps, and after following the steps, we will have a proper program, right? Or you can say algorithm is a step-by-step sequence of instructions that are used to solve a problem or complete a task. Understand? Okay, let's move on. Now, the first thing, if we are going to make any algorithm, how do we organize the program? So we organize the program with two things: decomposition and abstraction. Right? Decomposition and abstraction. So decomposition is breaking a problem down into a smaller sub-problems that each accomplish an identifiable task, which might itself be further subdivided. Like decomposition means that you are going to break a program in this way. Look, I'm breaking a problem like this into steps. Into the steps. Look, and then these steps into further steps. Did you get it or not?
Yes.
So in this way, we are going to divide or break our program into the tasks. And look, this is a main program, right? This is main program. And I'm going to decompose my program into the subtask. This is called subprogram or subtask. What it called?
Subprogram or subtask.
Subprogram. And then again, I'm going to break my subprogram into another subprogram. Look right here. So it is also called subprogram. So with the help of this type of structured chart, we can break our program into the small pieces. And that small pieces comes with the complete concept of our program. So we divide our program into the subprogram or subtask. So these are called subprogram or subtask. Did you understand this? Further, you can divide your program into the more simplified step, so the algorithm will be decomposed.
Okay.
Abstraction is removing or hiding unnecessary details from a problem so that the important details can be focused on or more easily understood. So abstraction means that you are going to, make your program easier by ignoring the unnecessary things from your program, unnecessary details. Like I'm giving you a very good example. Just a second. I'm giving you a very, very good example. So
What, like a GPS, for example?
abstraction, for the abstraction. For abstraction, I'm looking for a good example. Maybe it's here. Just a second, I'm looking. Oh no, it's not here. Look. This is an example of abstraction. Look, right here. Okay. So did you see two maps here? Like on the right hand side, I have a map, and on the left hand side, I have the same map. Which map is easy to read?
The right.
The right. Why?
Because it's more clear.
And it doesn't have any unnecessary road maps, colors, the map things. So this thing is called abstraction. Did you understand it or not?
Yes, understood.
So abstraction means that you are going to make your program easy. Look, abstraction keeps the key elements required for the solution to the problem and discards any unnecessary details and information that is not required. Like in this map, you can see in this map, there's no need of colors, of some mappings, of some valleys, hills, nothing. You can see here. Look, so there's nothing to use these things. So that's the reason we are going to use this map. This map is more easy to read. Did you get it?
Yeah.
Okay. Perfect. So there are some differences, right? There are some differences between decomposition and abstraction. So the first thing is decomposition, like a login, like they have given you some example, like how can the t-shirt sales be split up? So forget this thing. So take out your notebook. You need to write down three things first. First, the example of, first the definition of algorithm. Then you need to write the definition of decomposition, then abstraction, and then you need to make this diagram for decomposition. Look, this one. Okay, algorithm, decomposition, and abstraction. I want the definitions with this diagram. Do it now. So now the topic is about the structure of any algorithm. Like if we are going to make any algorithm, definitely the steps are showing, representing the three process. First, input, next is process, and the third one is output. Like without these three steps, an algorithm can't be designed. It can't be designed, right? So input means that you are giving the data, right? In order to understand the algorithm. So the user must type in via the keyboard or enter with another input device, such as a microphone, or read in from an external data file. So input is a way in which we are going to give something keyed in into our computer, right? Key in. It means we are going to do input. So input can be in any form, like with the help of the keyboard, like with the help of a scanner, microphone, any input device can be used. So the output is the data that is given back to the user by the algorithm. So once you are going to key in the details are going to be represented on our screen or any other output device such as a printer. Third is a processing. Processing describes a step that the algorithm takes in order to solve the problem. Like once we are going to key in the data first go into the processor, right? So the processor is responsible for all the data which the user keyed in, and it's going to process it. Once it is done, it is going to produce output, right? So these three cycles are always used in programming, in developing algorithms, right? I can't hear you.
Oh, yeah, okay, sir. I was muted.
Okay, no problem. So, okay. Now, the next thing in algorithm
Flowcharts. I remember my
is very
favorite.
important thing, flowcharts. So, flowcharts are the pictorial representation, pictorial, or you can say graphical representation of
Using
our algorithm. So once we are going to represent our program, our algorithm in a symbolic way, so we use these symbols, right? So the line is used to indicate the control, like you're passing. The process box is representing that you're performing something. The subroutine or the loop is representing that you are going to relate something in your program, right? Subroutine. IO box is a very important box. It represents the input as well as output. One more thing in processing right here. If you see an is equal to or this arrow in your program, this arrow, these both are assignment operator. I think you know this thing. They both are assignment operator. And if you see any assignment operator, you just come to know that this is a process. Then finally, you got a decision box. Decision box is always used in your program if you find what condition, like if, then, else in your program. Isn't it?
Okay, so there's new stuff.
Yeah. So once you're going to use an if, then, else in your program, it means you need to draw the conditional box. In conditional box, you have two options. One is for yes, and other one is for no. Understand?
Okay.
Okay. And the final is a terminal shape. It is representing the start or stop in your program. Right?
Okay. So we didn't take the how do we draw subroutine in flow chart? We only took the line process, input, output, decision, and terminate.
Which one?
Subroutine, we didn't take it yet.
Subroutine is used while you are using a loop in your program. Like it is representing the loop. Let me write it down. Like if you're using any loop in your program, like for next, like while do, or anything, which is a loop. So in this condition, we use the subroutine. Like for conditions, we use decision box, and for loops, we use a subroutine box. Is that all right?
Okay.
Just a second, let me see something. Okay, so do one thing. Now take out your notebook. First, you need to write down about the input, process, and output. Once you're done, you need to draw this diagram about input, process, and output, and then let me know. I will drag, and then we need to write down the flowchart symbols. Okay?
Okay.
Words.
Which like method is like describing an algorithm.
Program, like user input words. It is a textual English method of describing an algorithm, right? Like input.
Yes.
Like print.
English like method of describing an algorithm. So
like
it's similar. It has the same structure. It has the same. It's similar to in code, but it uses English like English like
structure. You can see AqA, it uses English structure, right? Okay.
Yes.
Now the program code, what does it mean? Program code is a set of instructions written in a high level language, right? So once you're going to use an input, use a process, and use an output instructions, so the program code will be completed.
So
like
can you please go up to the
sorry?
Can you please go up to the example that was up for the pseudocode?
For the pseudocode?
Yeah, the example that was up.
This one?
Yes.
Yeah.
Okay, can I just quickly write this down?
No, you just take the picture. So after my class, you can write down in your notebook, okay?
Okay, 1 second.
Because these are the things we have done. So I need to just flashback, only flashback. We are not making notes again, okay?
I took a picture, yeah. Sure.
Yeah. Okay, so program code means the well-defined instructions, right? So like they have given you an example of Python. Look, this is an example. So these are the program code for the Python, right? Like you are going to read it in this way. Now, the most important thing, the purpose of algorithms. What is the purpose of algorithm? The first thing is a trace table. Trace table is a method in which we are going to find the errors in our program. It is used to find the errors in our program, right? like the wrong values. Like what happened, the trace table will list each of code, all of the variables and the outputs. By filling in the table, you can track the content of each variable. So if you wanted to find out any error in the program, you can use the method of trace table, right? So by tracing this algorithm uses trace table, we can see that it makes a choice of whether to reorder the stock based on whether the current stock falls below the reordered level. Like these are some lines, these are some codes. First thing, in line number 1, item code, the user have to input. User input 009. Comments, item code 009 entered by the user. Now, stock level 009, that is input by the user. So there are 9 items of 009 available in stock.
8.
So stock level of 8 entered by the user. Like once you see there are 8 boxes of 009. So you input how many boxes are in stock? 8 boxes. So do you want to reorder it because there are only 8? So let's see what happened. A reorder level, the user have to input. It is 8 and the reorder level is 3. Like it's around 5 times more than, like 5 items are more than 8. So it is not going to be reordered because if 3 boxes are left, so we need to reorder it. Number 4, if stock level is greater than or equal to reorder level.
Less than or equal to.
Less than or equal to. So what happened? Is it less than?
Yes.
Of course. So it is not smaller than or equal to 3. So the line number 7 executed. So next is stock not ordered because we need to order if the stock level is 3.
Okay.
So stock not ordered. So this is how the trace table works. It works with the instructions. It works with the given
each line of
instructions.
the code. Through each line of the code.
Yes. Okay. Next topic. Okay, so we have
So
some.
can we do the
activity.
sorting of can we do sorting algorithms and searching algorithms?
Sorry.
Can we do sorting algorithms and searching algorithms?
Yeah, we will do. But first we need to revise the things, right? Okay, knowledge check. I'm giving you this activity right now. You need to do it in your notebook. This is of trace table. So you need to draw this table in your notebook in a rough way. So do quick in your notebook. Algorithms. So the first thing is in algorithms, we can write down the things as an input, then we can process it, and then we can do the output. So there is a simple algorithm right here, algorithm number 1. In this algorithm, you can see that we are going to initialize the variables. Like the first variable is A. It is a user input. And the second variable is B.
Second variable is B.
So both things are the variable which is being input by the user. Now there is a loop. While B is not equal to 0, like it is an A, it is an B. Both are the variables. Variable means that the user have to input the values in it. So if someone is input 3 in A and 6 in B. So if while B is not equal to 0, B is not equal to 0 means B is 6 here. So it is not equal to 0. If A is greater than B, like A if greater than B. Did you see A is greater than B?
Yeah.
No. So if it is not greater than B, then what happened?
Then you have to do B is equal to B minus A.
Yeah, so B is equal to B minus A means
I
6
think that-
minus 3.
so you're assigning B the new
So the answer
value,
is,
B minus A.
yeah. So output A. So what is the value of A now? A
The
is,
value of A is the value of A
yeah,
still 3.
it's still 3. Perfect. So this is how you're going to compare the things in algorithms. Now again, the same thing, algorithm number 2. We have A and B are the variable. We have GCD, a variable assigns at 0. Now, A is greater than B. So A is greater than B. So if it is, then A will be large. Else B will be large. So again, we have 6. So the answer is 6. So 6 is large, right?
Yes.
So in both programs, our value becomes B. Okay, now, and if. So for X is equal to 1 to large, what does it mean? Like if X is equal to 1 to 6. Why? Why I write 6 here?
Because it's the greatest number, it's the biggest number.
B is large, look here.
Yeah, B is the biggest number, that's why.
Oh yes. So now if A mod X is equal to 0, like you are going to use a mod. What is mod?
Mod, so I think mod was when you divide two numbers,
Yeah.
it gives you the remainder.
Perfect. So A mod X. So how many times a mod works? 6 times. And B mod X is equal to 0. So we can see the B mod as well. B mod X. So this time write like this. Then the value of X will be stored in the variable GCD. So and if, and for, and the value of GCD will be output. So in this way, we are going to define in any algorithm, right? So it's a comparative algorithm, conditional algorithm, in which we compare the two values, we assign a variable for the larger value, and then we compare it again. Did you understand? So this is how the efficiency of algorithm is done. Like we need to use algorithms in order to sort out our problems, right? Okay.
Right.
Bubble sort, searching. Now the next topic is sorting. Sorting means to sort your algorithm in alphabetical order, in greater or in ascending or in descending order. That is called sorting. Sorting means what? To sort, like a
Sorting isn't from like small cities.
set of instruction used to put up values of variable in order. Like you are using alphabetical order, you are using ascending order or descending order. Is searching algorithm. Searching algorithm is used to find a value within a list or to confirm that value is not present in the list. Like you're searching something, whether you find it or you can find it. So write down the definitions for searching and sorting.
Okay. What's the other type of sort?
So what happened in this question?
Yeah, okay. It's like a list of numbers, and it passes through each number, and it sees if
Compare.
the number. Yeah, and it sees if the
Comparison.
number is. Yeah, for example, here 7, it compares itself with 2.
So
If
it
7
goes
is greater
here
than 2, then they swap places. Yeah.
and it goes here. Okay. Now
Yeah.
listen again. Now we are going to compare these two. So these two are already in ascending order. So we are not going to touch them. So now you're going to use these two. So now you're going to swap them.
Yes.
Right? Now
Yeah.
you're going to.
And then compare 9 and 3, and
Yeah.
you see which one's the and you
You can
swap
see
them
right
again.
here.
But still,
Yeah, swap.
it's still not in order. So that's the first. So there's we have something called pass. A pass is when we go through it all and it's still not
And
if
Isa,
it's
very
still
good.
sorted,
Very good.
we go through it again. So that was the
Very
first
good.
pass. Then we have to do the second pass, and then we do the exact
Process.
same process until it's we keep on doing passes until the list is sorted.
How many passes are there in this question?
2, 4. Wait, let me see. 2, 4. No, 4, 3. 2. 2 passes.
How many passes?
2 passes.
2 passes. Okay. Okay.
Yes.
So now the merge sort. Do you remember about the
Merge
merge
sort.
sort?
Yeah, this one was my favorite one. Okay, if
Yes.
you have a list of numbers, you have to split each one into pairs of two. And then, for example, in this question, in this example, 7, 2, 9, 4, 3, blah, blah, blah. Let's take 7, 2. Okay, 7 and 2, we compare them with each other. It's 7 is greater than 2. So you have to swap them. It has to be 2, 7. And we do each one for each pair, same process for each pair. And then you have to merge the pairs with each other from in ascending order from the smallest to biggest.
Perfect. Perfect. So it
Yeah, I
means you
remember
have
this.
to remind all these things. Great. Okay. And this is how you're going to write down the merge sort algorithm.
Yeah,
So,
very easy.
so linear search. What is linear search?
Okay, linear search it uses like and I think linear search it uses the true or false method to see each one.
Yeah. Like we are
So
going to
like 7,
see,
it compares. Yeah, it's very slow. I remember it's very slow. So the C 7 and 2,
and
it
we are
says
going to
if
use a
you
repeated
repeat.
loop here. How? Look, check one value from the start. If value matches what is being searched for, then like if you're searching something, linear search is not going to compare. Linear search is going to search the value. Like if you're using search number 4, so they are going to
Mm.
search the number like this,
It's
that
gonna
this,
it's going to inspect
yeah.
each item, each value.
So output the value if you are going to search it, else move to the next value. So and if until the number is found or the list is reached. So this is how it works.
Yeah, it's
Understand?
easy. Yeah, it's but the main disadvantage between linear search and binary search, I remember, is that linear search is a slower method because you have to pass through each individual item. So, for
Yes.
example, so if we had like 100 items, it would be
Yes.
easier for us to go binary search because linear search you have to go through each one, each
Perfect.
item
Perfect. Perfect.
until you find the desired
So
answer.
so a more
Yeah,
efficient
binary search
algorithm
is
to
more
find
efficient.
values
Yeah,
in a binary search. However, this algorithm has a prerequisite that list its searches must be in order.
yeah, or else it won't
Search, we
be
don't have
valid.
follow any order, but right here we need to follow an order. So you can see like this work examples there, and this is an algorithm, right?
Yeah.
Okay, perfect.
Yeah.
So this chapter is I think done. This chapter is
Yes.
done today. So
Yeah,
you
we did
need
this.
to write down the algorithms for linear search, for binary search, for
Bubble
linear
sort of
binary, and let me see,
bubble sort, merge sort,
merge
and
sort
linear.
and
Basic
bubble sort, right?
okay, I know all the sorts in the linear search. The binary search, I need
Yeah,
to understand it a bit more because I don't really remember
no problem. You just
how
go through it. You just go through it, and if you have any problem, let me know.
yeah,
Okay.
yeah.
So I will
And
extend
so
your class of 1 hour. Okay.
okay,
Okay. Okay. Goodbye.
bye.